Hi, this morning we were going to be computing another limit. It's a one-sided limit, and it's actually going to produce a result that's of interest to you, and it's a technique that's very important. So the limit is the limit as x approaches 2 from the left, the little negative sign in the superscript of to the right of the 2 tells you which direction you're coming in at. It's not a negative 2, you're coming in from the left, of x over x squared minus 4. So we look at our form as always, and as x goes to 2 from the left, the numerator is 2. As x squared minus 4 goes in from 2 from the left, we actually get 0, which is a form, and we know that a number divided by 0, form-wise, it's actually undefined in reality, but when we're talking about limits, that we have an infinite limit right here. We're going to get some kind of infinity. Well, we need to determine what are we going to positive or negative infinity. So we need to look at the signs, that is the positive or negative sign of the numerator and the denominator as x approaches 2 from the left of x over x squared minus 4. And so there's really kind of a lot of thinking, so I'm going to try to put a couple steps in here. And one of the things, this isn't really necessary, but it makes it easier to kind of look at. We have x, I'm going to factor the denominator because I see that it's easy, over x minus 2, x plus 2. Nothing cancels. We've already known by looking at the form we don't have a hole, so we have some kind of vertical asymptote. So what we need to do is we need to look at that form again. You can put an equal sign there, I'm just hesitant to. As x approaches 2, or as from the left of the function x of the numerator, it just goes to positive 2. I mean, if you look at the graph, y equals x and 2, it approaches 2. It's that from both sides. There's just no two ways about it. On the bottom, however, we get as x approaches 2 from the left of x minus 2, we know we're going to get a 0, but I'm trying to show, so I'll just put a 0 there, and we're going to get that in the form of a number a little smaller than 2 minus 2 will be a negative number, and a number a little smaller than 2 plus positive 2 will be a positive number. So a positive times a negative is a negative, so we get 2 over 0 negative, which tells us that we have a limit of negative infinity. So the limit as x goes to negative 2 from the left of x over x minus 2, x plus 2 equals negative infinity. And if you graph that or look at that, personally I have a problem with saying it equals negative infinity. I know it's convention to say that. Just to me, a limit is a limit. It's a finite thing, but I don't have that much experience, so I'll accept it for now, and this is acceptable. That just, to me, infinity is infinity. But you do have a vertical asymptote there. This function goes to negative infinity when x approaches 2 from the left.